Good afternoon, everyone. Welcome to the last session of the GSSA on herding. Today, I'll be talking to you about what is needed to implement reherding in the South African agricultural landscape. And I'll be drawing on lessons from our work in Namaqualand on traditional pastoralism and how herding has been implemented there for centuries. The presentation outlined today will focus on rangelands, just an overview on rangelands and their distribution, and the dominant management practices within these rangelands, particularly in South Africa. I'll be talking about how the new thought processes around how we should value variability in rangelands and use variability as a resource. I'll be looking at, the need for alternative livestock management in South Africa and herding as an alternative livestock management by drawing on the key lessons from our work in Namaqualand. I'll also be talking about the challenges herders face in the country and what the enabling factors would be if we are to scale out herding in South Africa. If we look at the distribution of rangelands across the world, particularly the global atlas that was launched about 1 or 2 months ago, and we can see that 54% of the world's land surface could be classified as rangelands, and 78% of these could be classified as drylands. Drylands meaning your hyper-arid areas, your arid areas, your semi-arid areas, your dry subhumid areas, or any other area that falls within their definition. And if we look at South Africa, particularly, most of our total surface area could be classified as a dryland. Drylands in general are characterized by uncertainty, particularly in rainfall, and the variability in rangeland resources that would include water and forage availability. Rangelands, as we know it, are consistently undergoing change, whether it's from global drivers such as climate change or more local drivers as desertification or bush encroachment. And all these drivers, if you look at it, have an impact on the forage availability, on the forage quality or distribution within the rangeland. So where you would find food, particularly good quality food, is not constant, it changes with time. So to manage these rangelands, the varying resources, the variability in the resources of the rangeland, we have to look at a more systematic approach how we can manage these rangeland resources. If we look at the dominant grazing management approach in South Africa, and that's particularly the use of fences to implement a paddocking system, a 3-camp, 4-camp, 6-camp, 8-camp, multiple paddocks, which are used by livestock farmers to implement rotational grazing and rotational resting. So these paddocking systems have been developed over time and has been adapted by farmers suited to the local context. So they had time to build the knowledge and the skills to make the system work, and they also had time to establish the proper infrastructure on their farms. So farmers in general are quite comfortable with the system and it works for them. And they see any other form of livestock management, they see that as not conducive to them because of, for instance, the extension of Security of Tenure Act, which allows farm workers um, to have security of tenure on the farm, but also the responsibility of the farmer or the employer to look after the basic human rights of the farm workers. So farmers find the act very um, as a deterrent because they don't always have the necessary resources and the know-how and how to implement the act. But I will chat to you more about that later in the presentation because it is so critical in if we are to reherd the South African landscape to see how we can overcome the issue of the ESTA Act. But just fencing in general, it took time and money to develop. So it's not a cheap and a fly-by-night type of system to develop. And most likely, most interesting is that fences are actually, if you look at it at the variable, at the dynamic environment these days, fences represent something that's quite permanent, whereas there is much more variability in the distribution of resources. So at the end of the day, you could have a fence in an improper place. Through our work in livestock management, we've actually challenged the fencing system, and we wrote a few responses to the position paper in the special issue of the African Journal of Range and Forest Science in 2013 already, where we say that fencing is incompatible with rangeland commons. Fences were proposed and implemented in communal rangelands, but it actually didn't serve the purpose what the community wanted, and in a lot of cases it actually made matters worse. And farmers, particularly communal farmers, their objectives couldn't be reached. And we have an example where betterment planning and economic units were implemented, and sort of caused devastation within the community, because people were cut off from the resources that they usually access. So it caused havoc in many communal areas, and then that's why we argue that while fences do work in certain areas, there are many other places where fences do not work. Last week, Professor Ian Schoon spoke at the United Nations Food System Summit, where he talks about this new science of variability, whereby we have to take into account farmers' local context and their practices and indigenous knowledge. And we have to make use of this variability as a productive resource. And we can move between areas to exploit the changes in resource availability. So where conventional systems have failed, alternative systems are needed in order for us to respond to resource variability and uncertainty. And if we should ignore the variable context, we could end up developing inappropriate and harmful management plans or policies. And this is exactly what happened in the communal rangeland settings, what I was just referring to in the previous slide. So whereas fence systems focus on stability and control and suppressing a variability, he questions whether these systems are appropriate for confronting climate change. So why would we need an alternative livestock management tool? And I mean, herding has been practiced for centuries, basically in South Africa. In most parts of the, or few parts in the country, it hasn't died out at all, even though many attempts have been tried to suppress it and get rid of it. But it persisted, and we need to ask ourselves why did it persist, and particularly it persisted because it is the best tool to access rangeland variability and uncertainty. And it also, people who manage livestock through herders do recognize that the changes in the distribution and quality of forages at the local scale do occur, and they need to have a viable management tool to access this variability in resources. Herding is also being used as a restoration tool, and we'll probably hear about it later in the session, the work that the Landmark Foundation is doing. Very importantly, herding could be a job creator, and I mean, we'll talk about it later about the attempts to professionalize herding. But our national development plan talks about the need to create 1 million jobs in agriculture by 2030, and herding could certainly contribute to the job creation. UNESCO has declared herding as a heritage, so there's a need to continue herding. But most importantly is that we can also use herding to speed up land reform in South Africa, and I will tell you why I say that. Eva Slecht, in 2020, in a review on herding around the world, she described herding as a multifaceted approach or occupation with key purposes of directing animals to the most nutritious grazing areas in water. Where there are crop farmers in the area, herders need to prevent crop damage. They need to be able to keep herds apart if it's an open or a grazing system. They need to care for the newborn animals and also assist in lactating ewes. And then they also need to protect the herd from predators and stock theft. And no more in an Namaqualand context are all of these purposes relevant. So let us explore a bit, what the herders in Namaqualand do as well. Just to start off, just to give you an orientation when Namaqualand, where I'm referring to, it's basically the northwestern part of the country. Here there are six larger communal areas unfenced, the largest being more than 500,000 hectares. These communal areas are synonymous to the former Bantustan homelands because these were former colored reserves. So during apartheid, uh, Nama people were forced into colored reserves and they weren't allowed to have any um, ownership of land outside the communal areas. So the Namaqualand region is arid to semi-arid, and the area and the rangelands are unfenced. It's not cut up into fences, so livestock is being held at stock post and it's being managed by a herder every day. Most of the Namaqualand receives winter rainfall. Pella is exclusively in the summer rainfall, and it's mostly shrublands that dominate the landscape, particularly um, succulent shrubs, dwarf succulent shrubs. But if you move further east, you get into the grassy Namakaru. So the herders of the Makwaland, most of the herders are full-time herders. They could be as young as 71 years old and could be as old as 71 years old, as young as 17 and as old as 71, with a median age of about 55 years old. So the herders aren't young. Um, it's very, very rare to find a female herder that is full-time. And also the herders, they live at the kraal where the animals stay. They have their own shelter. And particularly if the stock posts where the animals are kept are far away from the village. You usually only get one herder per herd, but if you have larger herds, particularly more than 250 animals, or during the lambing season, there's extra labor to assist the herder. So in Namaqualand, the herd sizes range from 10 animals to 1,500 animals in one herd. So, and that speaks to this perception that communal farmers can't farm at a commercial scale because there are some communal farmers who actually have much more animals than the neighboring commercial farmer. So we just need to be careful of not always portraying communal farmers as at farming at the subsistence or small scale level. Some of them actually do have a lot of animals. There are only a few cattle in the communal areas, and the cattle aren't herded. If we are to explore the multiple roles of herders in the Makwaland, what it clearly shows is that a herder is not the security guard type of person that everyone thinks a herder is. A herder is actually a skillful professional person, in my opinion. And Clement spoke about it last year at the GSSA about the multiple roles of herders. And just to recap that, in order to be classified as a good herder, you need to manage the livestock grazing, so not to chase animals around the whole day. You need to be able to control predation levels, to assist the sick animals, and you also need to assist during the birth when ewes are finding it difficult. You also need to be very much knowledgeable on the local ecology of the plants, and that is important because you can plan your grazing route around where the most palatable plants are located. And also very importantly is that a herder is actually the asset manager. It basically manages the assets, the money of the farmer. So if you look at it, a herder's got so many roles to fulfill. And it's not just the person looking or just walking unattentively behind animals. How are the knowledge or how's the knowledge developed by herders? This is some of the work that we currently doing, trying to understand, the um, development, how knowledge is actually being um, synthesized within a herd system. And we through this, it basically shows is that there were indigenous knowledge being passed on by different generations, and but it's not only the indigenous knowledge that informs what herders are doing. They also rely on the local knowledge of a particular area, scientific knowledge, particularly from researchers, from NGOs, from extension officers, and obviously some of the commercial products that come into the communal rangelands, and also the little experiences that they have with regard to various aspects of livestock management, and they synthesize and they weave all of this knowledge systems. So what at the end of the day they have what we call an agri-syncretic knowledge of the livestock farming system. So it is not only indigenous or indigenous and scientific knowledge, it's a whole weaving of these different knowledge systems that they depend on for the decision making. So when farmers or herders have different knowledge systems, they perceive their rangelands as differently. They perceive their rangelands differently. This is some of the work that we've been doing regarding the local knowledge of farmers. And what we clearly want to show is that if you look at map B and C, represents two different herders, B being a younger herder, C being a much more older herder. So they have this perception or they have this understanding in the rangeland where their resources are located. Um, then we this year we also spoke about we've actually written about the methodology. If you want to understand herders and the knowledge systems, that is actually much better to follow a walking methodology than to sit down and interview herders, because it's in the felt, it's on their way to the water points when they interact with the animals where you can observe some of the things they are talking about, and it's also where they feel much more comfortable, and they've got the sense that you're much more interested in their work, and that is where a lot of the knowledge is being exchanged between the herder and the researcher. So they perceive the rangelands differently, meaning that they also implement graze or herding differently. This is the work that I did during a drought period in the Makwaland. And what I show is that I've identified 8 different herding strategies, um, largely based on whether they kraal the animals at night, how actively they herd the animals, do they herd the animals the same day, um, or the whole entire day, or do they herd the animals halfway, or do they herd the animals at all, or just open the gate and then go and fetch the animals in the evening. So there's a diversity of strategies. So if we talk about herding, we need to be careful not to generalize herding, because there are very different strategies that they employ, and the ones highlighted in red is actually the ones that are particularly that comes out during the drought period. Herders, obviously, they have different grazing routes. Some have shorter, some have longer grazing routes. But what this graph shows at the bottom right is that whatever the grazing route and the management option that they choose, a lot of them congregate on higher elevated areas during a drought period, because this is where they perceive the best forage lies. So they use various mechanisms to access this valuable resource during the drought period. You can actually say these mountains are key resource areas for livestock during the drought period. If we move out of Namaqualand a little bit and onto the highlands in France, um, I just want to make a few similarities between what the herders in France do and those in Namaqualand. Fred Provenza, he used a quote in one of his presentations. He mentioned that the diversity of edible plants can become only a food resource if the animals are motivated to eat it. So whether a plant has a good quality in terms of nutrition is not good enough. You need to motivate your animals to eat it. So on the bottom left, you can see a friend's herder and how he also views the landscape differently, where he cuts it up into different sections and this is where he plans his grazing route. But if you should turn your attention to the bottom right-hand figure, it shows that various parts of the rangelands are used for different types of how can I say meals. Whether the area is used to stimulate appetite, or is it basically just your main course where the animals get their food, or is that the area where you have to boost, or we have to visit before you can boost the appetite of herders. And obviously there are areas that are also considered the desert, the um, best grazing areas in the landscape. And as if you can see, after resting, when animals are young, herders never go to your dessert first because they are so hungry they'll eat up everything. So they go through the menu, the different courses first. Similarly, when we sit in a restaurant, we have to eat a couple of things before we get to the dessert, and it's exactly the same for livestock. So they, on a daily grazing orbit, they manage the livestock based on a grazing menu. And Michael Murray and Fred Provenza published their work in 2015, and also this work could be found in the book that they wrote about the art and science of shepherding. Now, in the Makwaland, research by the ARC in collaboration with French counterparts found a similar grazing menu being adopted by the Makwaland herders, whereby when they leave the kraal, there's first the appetite moderation, and then they reach their main course, and then there's a late afternoon meal. But also, very importantly, there are areas in the landscape that they do not want the animals to visit, and those are particularly the areas where there are poisonous plants. So there are 3 or 4 different variations of the grazing menu that was identified um, in the Namaqualand area. So similarly to how the French herders manage the animals, there's similar actions happening in the Namaqualand area. What I want to show here is that if you should compare herded versus unherded animals, you can see that there's a difference where the herded animals go and where the free-ranging or unherded animals go. So herders usually herd their animals where there are no free-ranging animals, particularly the free-ranging donkeys and cattle in the landscape. So they don't want their livestock to compete with the free-ranging animals. So they take their animals particularly into the mountainous areas. Now, if you graze different habitats, your animals also graze a different forage. Um, Herded or free-ranging animals have a much more now they have much more grasses and herbs in their diet as opposed to herded animals who really rely on your shrubs, particularly herded goats who actually rely on your perennial shrubs. So the competition for food, if you herd your animals, it's less because they don't have much competition with the free ranging and free ranging donkeys and cattle. This graph shows that, particularly if you should look at goats, that if you herd your animals, you're most likely to provide your animals with an option to select the forage quality that's closest to the forage quality on offer. So if you look at it during the dry season, the Euclidean distance for herded goats is much shorter than free ranging. And similarly, during the wet season, the Euclidean distance it's smaller than for free ranging animals. So if you look at goats specifically, you can provide your animals with a much better diet. But the pattern isn't consistent with what's happening with sheep. And it actually shows the opposite for sheep during the dry season, that it's better to leave your sheep unherded during the dry season because they're most likely to select a better quality diet. So herding does influence the quality of diet that is being selected by the animals. If you should look at, perhaps if we just turn our attention to other benefits of herding, if we look at the national stock losses in 2007, we can see that there's quite a lot of stock being lost through stock theft and predation, and the amounts are quite staggering. It's what almost a quarter of a billion rand losses to predation in almost 200 million in stock theft. So these are quite very sad and very shocking statistics that a lot of animals are being lost to predation and stock theft. And if you look at it, if you look at the Western Cape, predation is much more of a problem than in the Northern Cape. And one of the reasons could be that there's much more herding taking place in the Northern Cape as in the Western Cape. But let's explore this a bit further. If you look at the communal rangelands of Polshoek, and this is the data of Tim Hoffman at UCT, during the drought period in 2002 and 2003, your predation level was less than 5% only. So most of the animals that died are actually they died due to the drought. But you actually lose very few animals during through predation. And the longer the database of Tim Hoffman, I mean, he has, or a student of his has analyzed it over a time period of almost 20 years and found out that the overall, the long-term stock losses to predation varies from about 3 to 6%, depending on the sheep or the animals that, or the sheep or goats that you keep. This is in Bhutan, and it also shows that if you do not have a herder, you're most likely to lose animals to predation. And I think it's quite obvious that if you have an animal with his dogs amongst the herd, there's less likely that your animals will be attacked by a predator. And always, even the work of the Landmark Foundation clearly shows the benefit of herding to protect the animals from predation. This is some of the work that the Landmark Foundation is doing, and I just want to point out that if you adopt a much more wildlife friendly livestock farming system and you implement herding, you can actually um, improve the biodiversity, particularly the mammalian biodiversity on your rangeland. And this data clearly shows that in the last 3 years there's been an improvement in the number and abundance of mammalians on your farm. So this is some of the work that was published this year. So this is an additional benefit that herders can also bring, or herding can also bring. Yes, but herding, it's not, everything is not, all is not well with regard to herders, because they do get a very low salary, and it's a bit of an obstacle because it's lower than a minimum wage. But this problem is also happening elsewhere, where herders get a very low remuneration. But there are models whereby farmers give herders a share in the herd, and through time they build up their own herd, and then herders could move out of the herd and then they start their own herd. So there's some other forms of way of addressing the issue of remuneration. Also, when you have shares in the herd, you're also most likely to look better after your animals. Herders have to work for long hours in strenuous terrains, and it requires a strong dedication. They often tell me that herding was their calling, and that motivates them to be herders. There's generally a lack of supply of reliable and skillful herders. They do not stay in the most conducive living shelters. You have to be alone in remote areas for long periods of time, and there's no immediate support when emergencies occur. And most recently, particularly in the succulent Karoo, herders find it unsafe sometimes to be in the rangelands because there are a lot of poachers who are poaching succulent plants. Um, and then also, herders have mentioned that because of climate change, there's so many changes happening in the environment. They find it very difficult to adapt because their knowledge haven't adapted to the fast changing landscape. But there are initiatives going on in South Africa to look at the herder supply and to professionalize herding. And some of the work is done by the Herding Academy in Graafrenet, where they have an executive land management course and a professional herder course, with the aim of training herders, particularly in holistic livestock management. and also show herders that you can actually use the herd to regenerate your felt. Similarly, the Landmark Foundation has got a herding course with an accredited syllabus, but they also have a demonstration site to show farmers how herding could be efficiently implemented. So there are initiatives to improve herder supply and to professionalize herding and to make it much more marketable for youth. And then also it could be a vehicle to create jobs if youth are interested in herding. The Herding for Health programs implemented by the Peace Park Foundation, Conservation South Africa, University Pretoria, and other partners. They also have livestock management or herding training, particularly in areas where there's a wildlife livestock coexistence, the interface between wildlife and livestock. And they train herders, particularly in disease monitoring, herd health management, predator interactions, holistic management, regenerative agriculture. So they also have courses in herding that's more related to conservation. Then I mean there are opportunities for herders to be more than livestock managers. This is an, a popular article written by a Kenyan researcher Hussein Wario, where he talks about the need to bring back herders. Similarly, the call was made for conservation herders in Europe. But if you should look what the Kenyan researcher said is that because of COVID-19 and because of all the conservancies that they have in Kenya, and the functioning of the conservancies are so dependent on the income from tourism. And due to COVID-19, the tourist industry basically collapsed within the conservation conservancies, and there is no money to pay the rangers. So he said they should use the herders as conservationists to continue the work that rangers have been doing because they are on the ground every day. They just need better communication and a central communication system where they can report on poaching. I mean, herders could be used as conservationists in the Karoo as well. We all know about the tens or hundreds of thousands of succulents being confiscated every month. And why not use the herders in the veld as well? They are the eyes and ears on the ground. Although most of the plants being poached are not the fodder plants, but they do have very much interested in combating poaching. So conservation should use herders in the community to fight poaching, but it's very important that you do not create more structures in the community. Use existing structures to fight poaching. And obviously, similar to Kenya, you need to have open communication channels where herders can report poaching crimes. There's also been work done in order to create models how herder shelters could be improved. The top picture shows the herder shelter for herders in on the Landmark Foundation farm. It's very mobile. In the bottom picture, it's the dome-shaped shelter that was a project implemented under the adaptation fund, where ARC and local partners to develop a cheap, mobile, and very efficient shelter for herders that they can use and set up when they move between different grazing areas. So I've chatted a lot about herding, traditional herding today, but there are a few take-home messages that I'd like to give you is that there are benefits in herding. Benefits from you can regenerate your felt. There's social ecological benefit, other social ecological benefits, multiple benefits from herding. Herding can be professionalized, certainly through the courses being offered through various institutions, and it can attract youth, and it can also create jobs and make a meaningful contribution towards the national development plan. It's very unlikely that established and older herders will adopt herding, Firstly, because the system that they have works for them, but also they have the infrastructure to implement a fence system, and they do not have to have many people on the farm. There needs to be a very dramatic shift away, particularly how we use extension workers in agriculture, a shift away from just um, prescribing infrastructure development towards training these extension workers to show farmers that you can actually manage your animals efficiently with all this very expensive infrastructure. And one way to do that is through herding. So there really needs to be a mind shift from infrastructure towards training. We can actually use herding to speed up land reform. A lot of the obstacles in land reform is there is not enough money to purchase all the fences. Um, but you can, and it has been shown that you can actually farm without fences, and all of that money could be used by government for trading or acquiring additional land to speed up land reform. I mean, there's an example that one of my colleagues did a few years ago that says if you just use the money of the that you would pay to erect eternal fences, you could actually pay a herder at a minimum wage with a 10% salary increase every year for 13 years if you use that money that you have spent it with fencing. And obviously herding brings other benefits, less poaching, less and a few animals being lost to predation through stock theft. So those are also additional incomes that the farm owner can reap through herding. Then the very important issue is the issue of the ESTA Act. Um, the biggest um, fight back against herding is this act because farmers do not want many people or on the land. Firstly, because they can't afford the minimum wage, the prescribed minimum wage, but they do not know, how to implement all the regulations as set out in the act in providing um, herders with a basic human rights and the infrastructure. And this really um, alludes to the fact that there needs to be a conversation between organized agriculture, between the research and government, and how to effectively implement the act because it is a national act. We have to implement it, and it speaks to the basic human rights that our constitution is founded on. So we really need to have a conversation in terms of how we're going to deal with this act. But there have been a lot of few proposals in terms of local government taking over the service delivery to 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 herders and the families on the farm. But obviously, it needs much more discussion around how we can get around this ESTA Act because I feel that if this is the biggest obstacle to reherding the South African landscape, and we really need to find ways how we can deal with this. So that is my message for today. Thank you very much to listening for me, and I would welcome the questions later. Thank you very much.
Good day, my name is Will Smuts. I'm presenting on behalf of a number of authors, of which the lead author was Matthew Church, of a paper that was published in April of this year in Frontiers. And the title of the paper is Wildlife-Friendly Livestock Management Promotes Mammalian Biodiversity Recovery on a Semi-Arid Karoo Farm in the Karoo. This is one of the outputs from a project called Shepherding Back Biodiversity, a project of the Landmark Foundation. I've listed the web links where the article can be accessed. Should anybody want a PDF copy, they're welcome to contact me after this. Our study area is in the Great Karoo. It's part of the Nama Karoo. The farm is 45 kilometers north of Beaufort West in the Nieuweveld Mountains. I've also detailed the rain measures over the last few years. It's just notable that we went through an extensive drought in the period, though the normal average is about 290 millimeters of rain and the drought average just under 200 millimeters per annum. I thought it would be quite useful to detail the context in which this project took place. We are an organization that is particularly interested in carnivores and top trophic conservation efforts on production landscape. And it's notable that most of the top carnivores have been extirpated from their previous ranges throughout South Africa over the last 200 plus years. There's also been extensive introduction of livestock in place of plains game that was evident in the area before the colonial settlement of the area. And what is particularly notable is how the nomadic pastoralism was eventually replaced by land that was privately owned. And with that came fencing, much of which was actually a subsidy from colonial and subsequent governments, extensive establishment of artificial water sources, and the termination of the faunal migrations for which the place was famous for. This also resulted in the nature of the veld utilization changing over the last century or so, and with that an historical and continued human-wildlife conflict practices that have resulted in the decimation of many species, both intended catch and bycatch. We focus particularly on production landscapes and particularly livestock rangelands. They have notoriously been degraded from bad land use practices, low levels of biodiversity being resident on it in current day, and they make up between 65 and 70% of the land surface of this country. We as conservationists must focus on these areas for resolving global conservation challenges, particularly the biodiversity crisis, the ecosystem collapse, and global climate change mitigations, and if we fail in those former two, adaptations to climate change. In South Africa, livestock producers often cite carnivores as a major cause for their economic losses. In response, these producers often use indiscriminate lethal controls on an intensive and large-scale basis to reduce these losses. Mitigating human-wildlife conflict is a good place to start to reverse the negative trends that these production landscapes have on biodiversity, and therefore the focus of. We conducted a study a number of years ago which tried to evaluate the cost and benefits of lethal versus non-lethal human-wildlife conflict mitigations. This study was an important part of our understanding and development of the current project. We evaluated the impacts on production of using livestock protection collars, livestock protection dogs, and alpacas. And the results from the study was fascinating. We had recorded the losses on the y-axis of livestock units during the practices of lethal control and non-lethal controls that were implemented on 11 different farms represented on the x-axis. The surprising thing was that there was an improvement across the board in both the first and second years of applying the non-lethal controls, which was surprising as we expected a more haphazard outcomes. What was also particularly interesting from the study was that we found that the people that were practicing the high density, short duration grazing methods had significantly lower losses even during lethal and in non-lethal periods. This seemed to suggest to us that the increased human presence and the greater herd concordance amongst their livestock might have a protective effect. This and a further study that looked at the correlation between the presence of carnivores in camera trap surveys on particular land uses and the presence of higher biodiversity was also quite informative. And we looked across a wide-ranging area where we had conducted landscape surveys of camera traps in both the Western and Northern Capes. In those stony areas predicted. Each little dot on the maps on the left indicate where camera traps were placed in those surveys. And we found in all 5 vegetation types that where you had an increased number of carnivores, you had increased biodiversity and species richness, which was fascinating. And these studies together led us to conclude that producers seem to have better production where they employed non-lethal controls. Those controls were also cheaper than lethal controls over the long term, and high density grazing practitioners had fewer losses. Where there were more predators, there was more biodiversity, and of course the direct species impact of lethal and non-lethal controls were also of interest to us, never mind the ethics of the different practices. And that led us to ask the questions, what if we return to human herding as a management practice, remove fences, and together with non-lethal wildlife friendly practices, do an experimental trial to see what that would do for production and biodiversity. This led us to develop the Shepherding Back Biodiversity Project, which had an objective for the next 25 years to run a management experiment and establish herding as a management practice on commercial farms in a fenceless and a wildlife-friendly manner. We developed a research program, a monitoring and evaluation program, of which I'm presenting the early mammalian results. There's also avian results and vegetation cover. A colleague of mine will be presenting the latter. And then also I'll touch on some production outcomes, and the financial impacts will have to be assessed. The payment for the ecosystem services, I'll briefly touch on that, but it's not a focus of this presentation. And we also developed a learning site. Focusing on the research in this project, we wanted to understand whether wildlife-friendly livestock management would have a positive effect on the mammalian species in a commercial farming context. By wildlife-friendly, we meant that there were non-lethal predator controls practice, internal fences were to be removed. You can see well over 300 kilometers of fencing was present on this particular farm, of which we have removed 62 kilometers, but essentially breached all camps except the few camps we have retained. There's no wildlife hunting. We practiced ultra-high density, short duration grazing to mimic game migrations, ensuring heavy impact, short duration and long recovery periods. We had herders present with the livestock 24/7 and nighttime kraling of cattle and sheep, which were in mobile kraals that were moved every week. The research hypothesis was that mammalian diversity will increase with wildlife-friendly livestock management. The research methods involved setting up a temporal paired trial on the experimental farm through the conversion up to final establishment over the 4-year period, and then a spatial paired trial to compare the converted system against a conventional farm and a game farm. We use camera traps and the results from the second half of each year, calendar year during which we did the monitoring. This is the location of the research trial. The black farm indicates the index farm where the conversion took place over a 4-year period, 24,000 hectares. The red farm is the game farm, just over 5,000 hectares, and the blue farm is the conventional lethal control livestock farm. The black dots indicate where the camera traps were located. The camera traps surveys targeted medium-sized and large mammals. The temporal paired controls were on the index site, and the spatial paired controls against the game farm and conventional farm were done after the completion of the conversion on the index farms. We looked at mammalian species only, and we also assessed the relative abundance index. We got a thorough record of all the species over the period of the conversion of the index farm. In the temporal paired control, the experimental site, we got fascinating results which showed a consistent increase in the mammalian species. We also broke that down in small to large herbivores, predators small and large, and we could see a consistent increase across these species. This graph indicates over the temporal paired control trial of the experimental site how we reach asymptote in each year, and we can see the sequential increase in the species numbers over the 4 years that was recorded. Once the conversion was complete on the experimental site, we proceeded to do a paired spatial control against a game farm adjacent and a nearby conventional livestock farm, and we found a significantly higher species richness on the experimental farm as compared to the traditional farm and game farm, which were interestingly equivalent to the starting results on the experimental farm. We found mammalian species richness increased by 24% over the temporal trial. The herbivore showed a more evident increase of 33% and predators less of an 8%. The relative abundance was interestingly 73% of the herbivore species presented an increase in their relative abundance. 67% of all species showed an increase in the number of sites where they were occupied. In the final year of the study, Wildlife Friendly Farm had more mammalian species than the other two farm types. The latter two having a similar number compared to the onset of the experiment on the experimental site. Therefore, wildlife-friendly farming can restore mammalian diversity on production. I have not presented the avian species results nor the vegetation cover, the herd health benefits, the production data, and the financial impacts of the different methods. The payment for ecosystem services brand scheme also had some impacts which we're not dealing with here, and of course there were social impacts, empowerment and land reform benefits of the project which are worth exploring. At this stage I will only mention quite surprising how important the herd health management was that came through the project. We did daily counts, did daily herd health checks, and of course management related to it. I present here the production results only because I know this will probably be part of the questions. We tried to keep the herd health, herd size consistent throughout the management experiment. I'd like to bring your attention to the number of losses in the first year was close to 200, and we've been able to reduce them to 53 a year. There is an aberration in 2017 when we have 2 freak weather events which resulted in 500 sheep dying from hypothermia in the October and November period. So we've extracted the results of those freak losses and presented the results as follows. You can particularly see almost the complete disappearance of carnivore losses in the period of human herding. We also didn't go into the details of establishing fair game as a brand scheme where incentives and higher prices, produce prices, are paid to farmers that practice wildlife friendly and ethical practice. Won't go into that now. We do want to acknowledge the many collaborators and funders that made this possible and helped us set up this project, which we hope to run for a full generation of 25 years. And we gratefully acknowledge all the participants in this.
Good day, my name is Janine McManus. I'll be talking about the research done on a farm in the Nama Karoo, looking at the recovery and compositional change of vegetation after high impact trampling events. The Nama Karoo is a semi-arid biome in South Africa, and it was known to once host historical migrations of millions of ungulates that used to move through the landscape occasionally. And these migrations had such high densities that, according to the diaries of the guys that saw all of these events, you couldn't see the soil itself because of the density of these of springbuck and zebra across the landscape. These migrations ended in around 1896 due to various aspects, including hunting and the erection of fences. And the dominant land use was quickly turned to livestock production. The area is known to have vast degraded landscapes, and the vegetation is also known to have quite slow recovery rates. The degraded landscapes are considered a result of mismanagement of grazing, such as continuously selective grazing practices, and due to the variable rainfall. Ultimately, this resulted in vegetation structural change to become a shrubbier environment with fewer grasses and ultimately fewer palatable plants over time. There was an increase, or there is a continuous increase in annuals and decreasing perennials, and there's increasingly loss of topsoil due to erosion. Now, these unsustainable farming practices make livestock production a vulnerable entity and unsustainable practice, and it also threatens biodiversity. So to restore these landscapes, an aspect that's known to restore landscapes is to ensure the return of palatable plants and, of course, increase the grazing capacity of an area. So employing production practices that promote rangeland restoration has benefits for both livestock production and conservation goals. Since the area once hosted vast millions of ungulates, we wondered if mimicking these historical migrations using livestock was a way to potentially reverse the negative trends of degraded landscapes that were known to be caused by livestock. So we considered that if we use livestock as a surrogate, we would use human herders to shape the herd to increase or decrease the impact on the veld. The continuous movement of the animals moved slowly by the shepherds would result in them having less selective grazing impacts on the veld, and so you would impact both palatable and unpalatable plants. These grazing practices of high density grazing practices would be undertaken in a planned rotational grazing system, and so you would have a high impact for a fairly short period of time followed by long resting periods. There should be more fertile soils because of the dung and urine from each individual sheep, which is then mulched into the ground by the hooves of the animal behind him. And this should ultimately fertilize the soil and improve primary production. Ultimately, that should then increase your livestock production at the same time by increasing grazing capacity. Livestock losses to predators should decrease because you've got constant oversight by the shepherds. And because of the mulched soil, the water should be able to absorb more effectively, and you'll have less runoff. Ultimately, you'll have an improved, restored ecological function to the landscape. The study took place on a farm in the Nama Karoo, about 45 kilometers northeast of Beaufort West on the Neverveld mountain range. The rainfall since the start of the project has been variable. The average, or the normal average rainfall for the area is usually around 290 millimeters. So 2017 had just above average rainfalls, followed by years of quite drought-stricken conditions. We assessed 11 kraal sites. Each kraal site hosted around 1,650 sheep for 7 nights in an area of about 2,500 square meters, allowing approximately 1.5 square meters per animal. The ages of the kraal site varied from 1 month post-kraaling to 39 months post-kraaling. Data was collected in May each year, data was collected from 25-meter strips inside the kraal and 25-meter strips outside of the kraal. Within that area, we recorded plant species, the growth form of the plants, the life cycle of the plants, the cover, the height, and we also collected nitrogen components of shrubs inside and outside of kraals. And then we also had 5 1-by-1 meter quadrants inside the kraal, and again 5 1-by-1 meter quadrants outside of the kraal to determine density of plants. Here's an example of the 25-meter strip inside of the kraal. The picture on the left indicates the strip that has slightly greener, slightly taller plants, and it just indicates how important it is to exclude wildlife grazers with that strip being fenced, as well as any potential livestock perhaps coming around and regrazing that area. And then in March 2020, it's that same strip just after rainfall. This is the same strip looking from the non-kraaled area, and this points out the beginning of the inside and the outside of the kraal. Here's another photo of a kraal site, and I just wanted to delineate the inside and the outside of the kraal. To the left is where the kraal site was, and to the right is just outside of the kraal. This is the dominant grass species in this kraal, which is an Aristida diffusa inside the kraal, and the same species just outside of the kraal. And you can note the mulched soil inside the kraal, a lot of dung compared to outside the kraal, where there's a bit of compacted soil and exposed soil around. So the nitrogen content of the shrubs inside and outside of kraals were tested from 2 months since kraaling to 12 months since kraaling, and there was a consistency of higher nitrogen content inside the shrubs inside kraals compared to outside of kraals. We compared the canopy cover of grasses and shrubs in and outside of kraals from 2018, 19, and 20. In 2018, grasses recovered rapidly, while shrubs were significantly lower inside of kraals. The total vegetation cover was not significantly different in or outside of kraals. In 2019, total vegetation cover was significantly higher inside of kraals, but this appeared to be driven by grasses, as shrub cover was still higher outside of kraals. In 2020, we found that the total vegetation cover inside of kraals was again significantly higher than outside, and that shrubs had appeared to recover, and there was no significant difference between shrub cover inside and outside of kraals. It's interesting to note that in 2018 there was only 66 millimeters of rainfall, so seeing a fairly rapid recovery in total vegetation cover was encouraging. 2019 also had a lower than average rainfall year with about 168 millimeters, and then 2020 had a more average year with around 280 mils of rain. Regarding the density of plants inside and outside of kraals, we found that there was no significant difference between the total plant density. However, we found that perennial grass density was significantly higher inside of kraals. We looked at the relationship of annual and perennial plants in and outside of kraals in correlation to rainfall events. Now the black and the red lines indicate inside of kraals. And if you have a look at the convergence where there's a shift from increasing annuals to increasing perennials around the 500 millimeter of rain mark. At that point, perennial plants increase and annual plants decrease. If we have a look at the perennial plants outside of kraals and the annual plants outside of kraals, their convergence reaches after around 750 millimeters of rain. That is at the point before perennials start outnumbering the number of annual plants, suggesting that there's a far more rapid response by plants inside of kraals compared to outside of kraals. We also assessed the grazing index value of the plants, and the GIV was significantly higher inside of kraals overall, with annual plants showing no significant difference, and perennial plants had a significantly higher grazing index value inside of kraals. The grazing index value for grasses were significantly higher inside of kraals. We observed significantly higher GIV for perennial grasses inside of kraals, while annuals had no significant difference. During the study, there were also other interesting observations, such as kraal sites that were placed on very flat landscapes that were completely denuded of topsoil previously, had recovered. Initially it looked like a lot of annuals, and then shrub recovery came through overall, but ultimately it does appear that kraals can be used in other applications such as erosion management. So in summary, intensive trampling events appear to promote rapid recovery of vegetation. The outcome is a grassier vegetation composition. There is improved forage quantity and grazing value, and a transition to a more palatable perennial vegetation type. There appears to be a more rapid response to rainfall events. Ultimately, the landscape becomes a mosaic of these nutrient-rich patches. Then kraals also appear to be suitable to restore degraded landscapes. Overall, trampling can be used to regenerate landscapes for the benefit of both livestock and wildlife. These results have relevance as 69% of South Africa is suited and largely used in the livestock production sector. Livestock production practices that reverse degradation and regenerate ecosystem function and biodiversity is increasingly important, especially in the face of global climate change. This work couldn't be done without collaborations by essential stakeholders, including willing farmers, the ARC, Grootfontein Agricultural College, UWC, Scion, Renew Karoo with Sue Milton, and other international universities such as the University of Technology, Sydney. Thank you very much for your attention. If you'd like to reach me, you're welcome to contact me on my cell phone or on my email address below. If you have any questions regarding the Shepherding Back Biodiversity Project or the effects of trampling on vegetation by livestock.
Hi everyone, I'm Johan Bauer, and this is my associate Sarah Cromot.
And welcome everybody. We are from the Herding Academy and we're based in Graafrenet, and I'm going to now hand over to Johan to tell you a little bit more about us.
Okay, so if we can go back and please join us for the next PowerPoint presentation. I'm going to run through you a short history and how we founded the Herding Academy. Right, the Herding Academy was founded in 2016. I came to the farm around 2013, and we saw the degradation in the Karoo, overgrazing as well as overresting, And we soon realized that the cause of overgrazing is not too many animals, but animals spending too much time on the same land. And that's basically a problem which we face in all our private game reserves and all our national parks all over the world is experiencing the same problem, where you don't have the effect, where animals are constantly grazing and there's no time control. So animals don't move anymore. If you think back in the Karoo, what happened hundreds of years ago, with not even that long ago, with herds migrating through the Karoo, I took that as a sort of a natural occurrence, and I asked myself, well, how can we mimic those migrations and restore the veld through that process? That is when I met Alan Savory and was on one of Alan's courses, and I realized that this is the only option that we have, is actually to introduce a lot more animals on the land, grazing them to a proper grazing plan, and then and that is what we started with. And the results, in the beginning we were quite skeptic. That was around 2015, 2016. We did trials, and we saw the results within the first couple of months, which was very exciting. So it was so exciting that we decided to form a curriculum and register it, and we founded the Herding Academy officially in 2017. That is, and during that time, we also took hands with our partners, the Peace Parks Foundation, with the Herding for Health program. Conservation International was a partner, and that was quite an important step for us. Is to introduce the professional herder course, the first of its kind in the world, to these organizations, and we've been training students since then.
The holistic principles that the Herding Academy is based on is holism, the brittleness scale, time control, and the role of herding animals. Holism is understanding that everything in nature works together. The brittleness scale is understanding that certain areas function differently based on the atmospheric humidity. Time control is understanding that you need to give give a plant enough time to recover after grazing. And then the role of herding animals is basically bunching animals together and moving them based on a grazing plan.
So the courses we started was really based on those principles, which forms the foundation of our learning experience. But we soon realized that you cannot only train herders per se, but you also need to train decision makers, and you also need to train the general farm worker or the general person that lives on that land. So it's more of a community and a social aspect to that development. So we developed the professional herding course, and soon after that we started developing the executive land management course, which is a regenerative course for land owners, for decision makers, for government agents, for implementing agents in parks and in other NGOs, which is a top level, almost a business executive level training, and that we do over 5 days in Graaff-Reinet. And it's really an eye-opener. The other course that we've also started is then where we have a bit larger groups in which we can go out and we can visit farms, we can visit rural landscapes, and we address the locals there. We do sort of group training, so people start understanding those principles that Sarah has just explained to us.
And then the professional herders course, we've really taken that and created a 3-month program, a CATSETA accredited course, that's then followed up by a mentorship program. And the mentorship program is crucial, that we keep in contact with the students once they've left us here in Graaff-Reinet. And then the curriculum that we look at with the professional herders course, we really focus on conservation and ecology, animal care, and a lot to do with low stress stock handling, research, financial management, personal growth and leadership, and then basic first aid. And we also focus on a lot of additional life skills with the students. And we also do a train-the-trainer course where they are able to basically take what they have learned at the Herding Academy and then go and train their community members back home on regenerative agriculture and the principles of holistic management.
So if I can add on to Sarah, is that the professional herder curriculum is based only on the herders. These are not the executive level training. This is also not the bottom end training. So if you really want to find out more about the other two courses, please visit our website. And it is quite important to understand the context where the Herding Academy originated from, and that is the context of bridging wildlife and the whole social aspect to bridging the conflict between humans and wildlife. And how do you, from a socioeconomic aspect, improve those landscapes, but also improve the livelihoods of people around those landscapes? That's why we're trying to focus on training students in areas and conservation areas where there's constant conflict between wildlife and humans, and how we can really use domestic stock to improve the landscape, but also improve the economic and social welfare of the people. And if you can take care of the land, then you can take care of the people. And it's been such a wonderful journey for us to see the results all over Southern Africa. And it started really small. It started on the farm where we saw the results. But also, I think I should also just mention, Sarah, that the people that really started this whole thinking and paradigm that I sort of copied almost was the whole idea behind forming transfrontier parks and peace parks and opening up migration patterns or migration areas for those big wild herds to move through to other countries, and where people like Nelson Mandela, Prince Renier of the Netherlands, Dr. Anton Rupert came together, and they founded the Peace Parks Foundation with a whole idea of opening borders to migrations. And we never thought that it would be possible that animals would have such a social impact through restoring and restoring the landscape, but also bringing tourism to areas and creating not only peace but welfare between countries. And the same principles, those same principles, is also very applicable to farms and to communities around farms, especially your rural areas where you can really go in. And we see this happening now, where some of our students went into areas in South Africa and areas like Zambia, where they're in the far rural areas and where they really make a difference in their communities, make a difference in how they understand how the regeneration of the land works. So that's the really exciting part. So we would really like to invite everyone to visit our website and Instagram, Facebook pages. Follow us, keep up to date, and we will be, and also to visit us. Please feel free to come to the Karoo. We're open. We have an open door policy. You can spend time with the herders in the veld. You can see, you can really come and experience what nature tells you. And really, like our guys always say, the herders also says, really to be able to understand the language of nature.
Thanks, Johan. And I think just to add to that social aspect that you were talking about, we've had 34 students that have gone through the professional herders course, and each one of them have been deployed into areas throughout South Africa, Namaqualand, up in the Kruger areas, Hoedspruit, and then as well as Matatiele. And then we've also got students based in Botswana and Zambia in the Simalaha areas. So and all of them have got jobs with their grazing communities. So it's really great to see that impact on their social status within the communities.
Thank you,
Yeah,
Sarah. I
thank you.
think that's it. I think we're running out of time. Thank you for the presentation, and thank you for the opportunity to present the Herding Academy.
Thanks.
Greetings, colleagues. My name is Andy Swafina. I work for the Agricultural Research Council and I'm based in Grahamstown. And today I'll be presenting to you some of the results from my MSc students project titled Assessing the Effect of Herding on Livestock Grazing Patterns in the Amakuzeni Communal Rangelands using GPS trackers. Just as a background, Eastern Cape is made up of the former homelands which have a long history of economic neglect and are mostly rural. And the ability of rural people to make a living is linked to agricultural practices, including livestock farming. And livestock itself is a key commodity of human well-being and provides social benefits such as food, income, nutrients, employment, traction, and others. And sustainability of livestock greatly relies on well-managed rangelands. However, in parts of the former Ciskei in the Eastern Cape, communal rangelands are described as severely degraded. And this degradation is attributed to a number of factors, including the absence of a livestock and rangeland management strategy. As a result, unregulated continuous grazing occurs in most villages. Where livestock is only led to the communal grazing in the mornings and collected in the evenings or late afternoon. We're leaving the cattle to free range, which promotes overgrazing of certain areas, as the animals would from different households will be using the entire communal grazing without having any portions that are rested. Hence, there is a need to explore a rangeland management strategy that will promote the optimal utilization of the communal rangelands. The aim of the study is to assess the impact of herding on livestock grazing patterns using livestock GPS trackers, with the objective to establish the grazing patterns of herded and free-ranging cattle, as well as assessing whether there is a difference in the grazing patterns of the animals that are herded and those that are free-ranging. And secondly, to determine the herbaceous species composition within frequently grazed spots for both herded and free-ranging cattle. To do this, three sub-villages, namely Guguka, Gilton, and Sombondo, which form part of the Amakuzeni Tribal Authority located in Alice in the Eastern Cape, was selected. And this area receives about 450 to 600 millimeters of rainfall annually, with the average temperature of 19 degrees Celsius in winter and 28 degrees Celsius in summer. And the vegetation types are the Amatole montane grassland, Bishothornfeld, Eastern Cape escarpment thicket. In establishing the grazing patterns, cattle from 10 households, there is one per household representing a herd, were fitted with GPS tracker collars in the wet season of 2017. 5 of these households had agreed to herd for 8 weeks, while the other 5 were asked to continue with the standard management practice, which was to allow the animals to free range. Then after 8 weeks, the collars were removed from the livestock and data from the trackers was downloaded using the catalog software and stored in comma-delimited ASCII text format and Google Earth keyhole markup language, that is KML files. And then the KML files were then displayed on Google Earth Pro, where a series of points represented the livestock grazing patterns. The GPS points were then used to create grazing density maps in ArcGIS version 10.2, indicating which areas within the communal rangelands were most preferred by the animals fitted with the GPS trackers. The preferred areas were regarded as those that were visited frequently on different occasions by the same animal over the weeks the collars were on the livestock. And then the areas were marked and digitized from the density maps, and herbaceous species composition data was collected from them. And to determine the species composition within the frequently grazed areas, a point-to-test method was used. And at each sampling site, 300-meter line transects were established up the slope, and the nearest rooted perennial herbaceous plant could be grasses, trees, and dwarf shrubs were sampled at 1-meter intervals. Grasses and karoo bush species were then grouped according to their frequency of occurrence and their grazing statuses, which are either decreasers, increaser 1, 2, or 3. And these are the results. So here we have a Google Earth map showing that is showing how the points representing the positions where the animals had been on the grazing are displayed. So this is how one of the animals that were fitted with the GPS collars and that was headed from Gildoni utilized the grazing over the period of 8 weeks. And here on this bigger Google Earth map, we can see that we have both the headed points, that is grazing patterns of the headed and the free range cattle. The headed is represented by the green points and the free range is represented by the yellow points. And this is for all the animals together, how they utilized this grazing of this Amakuzini area. And here within these red boundaries, they represent the arable plots and the residential plots. Here we have Sompondo arable and Sompondo residential, and here we have Kukuka residential, and then Kukuka arable lands, and here we've got Giltoni settlement and Giltoni arable fields. And as we can see from this, the animals that were headed in, especially in Kukuka, spent most of their time grazing within the two arable plots than they spent on the actual felt. And in Giltoni, we can see that most of these animals, whether they were headed or they were free ranging, they spent most of the time right on the slightly slopey area of the grazing of the communal grazing, but none of the animals are found on top of the mountain. So none of the animals grazed on top of the mountains. And then we have this blue here, which are the dams. And here we've got our grazing density maps. The density maps, the blue on these density maps and the bright yellow or bright creams, they represent the areas that were mostly frequently visited by the animals with the GPS collars. And on top here, we've got density maps for the headed animals. And at the bottom here, we've got density maps for the free range animals. Unfortunately, we could only download data from 9 collars as one of them had a malfunction. Hence, we only have 4 free range density maps here. And on this map, we can see here that these red dots are the points that were deemed or were digitized or marked as the frequently grazed spots. And as I had explained in the previous slide, we can see that most of these points in Guguga, they fall within the arable plots and closer to the homesteads. And here in Giltoni, we can see that these mostly found on the grazing area, on the actual communal grazing area, as well as here in Sompondo. They are found on the communal grazing. However, as I've said before, none of the animals were grazing on top of the mountain. So all of the animals focus their grazing on the foothills, on the arable, and on areas close to the homesteads. And just here we have a table showing the dominant species of each of these grazing spots. For instance, for this cow, which was named as GQ2, which was headed on the 3 grazing spots that were identified, we can see that the dominant species were Cynodon dactylon, Sporopelus africanus, and again Cynodon dactylon. And what we also observe here is that 3 species were dominant in most of these spots, which is Cynodon dactylon, Eracrostis plana, and Thermida triandra, and we only see Sporopelus africanus from one animal. And here, this is just the overall species composition within the frequently grazed spots of the headed cattle. And we can see here that the most dominant, or the 3 most dominant species were Eracrostis plana, Cynodon dactylon, and Thermida triandra. And for the free range cattle, we can see that again we've got Cynodon dactylon, Eracrostis plana, as well as Sporopelus africanus as the top 3. So then we can say that these results show that the grazing patterns of both the headed and the free range cattle were focused on areas close to the homesteads, arable fields, and foothills. Only cattle from 3 households, 2 headed, of which 2 of them were headed in Gildon, were shown to have grazed up the slope. None of the animals went further up to the mountains where good grazing was perceived to be in abundance. And this grazing closer to the homesteads can be attributed to fear of stock theft for free ranging cattle, while for headed livestock it could be the lack of herding knowledge from the herder's side, since they are only used to unregulated grazing. And for the herbaceous species composition, as I have mentioned, the results showed that the most dominant species that were found on those frequently grazed areas were Eracrostis plana, Cynodon dactylon, Thermida triandra for the headed animals, and Sporopelus africanus for the free-ranging animals. And the type of species encountered in areas frequently grazed by headed and free range, as we can see, did not differ much. So these findings can be an indicator of the long-term grazing pressure on areas both the headed and the free-ranging animals frequently visited during the 8 weeks period they had the GPS collars on. And owing to these factors mentioned above, it can then be deduced that in this case, herding did not influence livestock grazing patterns in all 3 sub-villages. These are the references. Thank you for your time.
Good day, my name is Clement Kevedo, and I'll be presenting this paper on behalf of myself and my colleagues William Ellis and Ihsan Samuels. The early Nama-speaking pastoralists adopted a type of transhumance movement across long distances over the country, even across the Garib River into the now Namibia and Botswana regions. And after colonization, they became spatially constrained as they were limited to mission stations that were later termed colored reserves. And these colored reserves became very important sites for the amalgamation of indigenous knowledge, as within these areas, knowledge systems that were derived from outside were mixed with their indigenous knowledge. For those of you not familiar with communal areas, this is just a map to illustrate where they are. There are 6 communal areas in the Namaqualand region, the largest being the Richtersveld, where we have done some work on climate change with communities. Also the Steenkop region, where we've done lots of research, and the Lelyfontein communal areas. So who are the herders of Namaqualand and what do they do? If we look at the definition from SCAL 2020, it sums it up very, very efficiently. It is a multifaceted occupation, and it's all about ensuring suitable nutrition for the livestock, directing livestock to nutritious grazing areas and water points, preventing crop damages, as some herders or farmers still do cropping in this region, keeping different herds separate, especially at the water points, caring for the newborn animals, milking of lactating ewes, and also the protection of the herd against predators and stock theft. So if we look at herders specifically in Namaqualand, if we look at Ihsan Samuels' studies, full-time herders, the age varied from 17 till 71 years of age, and the median age is about 55. The herd sizes average around 250 animals, and it can be from 10 animals or less up to 1,500 animals per herder. They mostly farm with bull goat almost exclusively, and also sheep, which are hybrids of Dorper, Damaras, Afrikaner, Persians, Meatmasters, and also Swakara. If you look at the picture on the top right hand side, it gives you a good indication of what a typical stock post look like. With a kaya where the herder sleeps, the koekskerm where he prepares his food, and the kraal where the animals are kept at night. This is a low input agricultural system. It's an open system, there are no grazing camps, and there are different herding strategies that are followed during the day. So there are several of these movable or permanent kayas throughout this region. And some livestock owners practice cropping, as I mentioned, for supplementary fodder for the dry season. So the aims and the objectives of the study. The objectives is basically to illustrate how agri-syncretic knowledge utilization by herder in their decision reflect a blend of indigenous, scientific, and idiosyncratic knowledge systems. I will elaborate on this in the following slides. And we look at it under these three topics: climate and weather prediction and adaptation, veld utilization and management, and livestock management. A further objective is to illustrate that herding is complex and it is multifaceted, and it relies on an array of knowledge systems, as I mentioned above. Our methodologies was quite diverse, and it ranged from observations from the natural science world, as well as a whole suite of methodologies used in anthropology, like walking interviews or go-along interviews, where we spend time with herders in the veld while interviewing them. We did observations on the types of plants animals engage with and how animals engage with the plants. We also did semi-structured interviews with herders, one-on-one interviews. And we also did photography and journaling to capture elaborations, interactions, and non-verbal expressions. We also used a technique called deep hanging out. As you can see in the picture, my colleague William Ellis with a herder, and this assisted in developing a relationship between the herder and the researchers, and also allowed for deeper and relaxed engagement between the researcher and the herder. Just to elaborate on the concepts, the term agri-syncretic suggests that there are certain traditional farming systems that farmers use, that the herders use, and they weave it in multiple ways to produce a new knowledge system and framework that is unique to that region. In terms of indigenous, just to clarify that, it reflects a group-wide set of phenomena that operates over large time scales. It can stretch over generations or even centuries. And it also includes elements of culture, called cultural rudiments and values. And this is a range of beliefs, cosmologies, traditions, and this is very place specific. And then scientific would be easy. What we mean by that is the adoption of farmers of certain feed technologies, herd management systems, breeds, genetics in treatments, for example, that stems from the scientific world or the commercial world, as a matter of fact. And then idiosyncratic practices, this is based on one specific individual or one specific household's experience that will give this specific particular individual a specific advantage over other people around him. And this is when new knowledge or techniques are developed based on all of the above knowledge systems. So if we look at climate and weather predictions and adaptations, just to illustrate, from the indigenous point of view, what we know that what herders look at is the shape of the moon to delimit specific subseasons, and this is especially important in determining planting seasons. If we look at short-term weather forecasting, there's the observation of cloud formation, cloud shapes, activities of animals like tortoises, termites, etc., wind direction change, temperature changes, and the absence of frost. And scientific, it would be, again, easy from our perspective, is how weather is predicted through models, through seasonal forecast, the development of early warning systems, weather forecast and radio, for example, how this is transferred to people on the ground, and then also cell phone apps like the YR apps. And then if we can explain idiosyncratic in this regard, many farmers make use of triangulation of one or more of these knowledge systems to predict the weather or seasonal forecast. For example, they won't only rely on indigenous observations, but they also look at scientific observations and they combine that in that regard. As I mentioned, then on veld utilization management, if you look at the three categories, again, indigenous, scientific, and idiosyncratic, we identified taxonomy, pastures, and ecology as the three aspects in veld utilization management. And I'm not going to go into much detail of each one of them, but just to say that Nama people, or people from Namaqualand, has got their own indigenous taxonomic systems where they talk about nibbies or tebi, and then they are also aware of the normal land classification system, and also species based on increase or decrease species based on agricultural terminology that are used to describe more palatable species that decrease under heavy grazing. And then they combine that knowledge through the use of a complex classification system based on ecological value, fodder value, and the sensitivity that they observe of the animals grazing these plants. And then shortly on pastures, they also speak about sweet veld and sour veld, and I assume this is where the agricultural term is derived from this indigenous knowledge. And they talk more about the local and area-wide palatability rating compared to what in science you will speak about a specific palatability rating. And if you look at the idiosyncratic, I would just want to highlight one example from that. The last point, the collaboration with ARC, is where one of the plants, Calabotus sericea, was identified as a possible fodder plant in cut and carry, but also to plant them to produce feed for drier periods. So currently there's a project running like that because of these idiosyncratic knowledge systems of farmers. And then under ecology, they make use of local grazing routes as explained by Sean Samuel's work in and around Polsuk region. And this is how they make use of the indigenous knowledge in search of better forage and also around water points. They are aware of phenological stages of the plant, grazing intensity of the plant, the occurrence of poisonous plants, and they move the animals away from these poisonous plants to plants that have more nutritious value for their livestock. And they also move the livestock, the stock post between different rainfall regions to allow for rest. If you look under the commercial knowledge, they are very much aware of paddock systems that are used by commercial farmers, and they mimic these aspects of grazing, of movement, and they also look at grazing intensity as that is learned from commercial farming or from research as a science aspect. And they're also aware of keystone species and endemic species. If you look at the third column under idiosyncratic, I just want to point out that they make use of specific indicator plants, like in the Lelyfontein region, to determine the livestock movement. This is one of the plants that was identified as an indicator species in terms of for its sensitivity to grazing intensity. In terms of livestock management, we divided it in two separate categories: ethno-veterinary and predator control. I will just touch on a few of them. Under ethno-veterinary, they make use of indigenous knowledge and the indigenous remedies that is plant-based. They also got indigenous specialists in the villages who can treat or who's got the knowledge to treat animals, and they also make use of household practices to treat animals. From the scientific side, most of them make use of inoculations, pharmaceuticals, and also they make use of veterinary services. But where the idiosyncratic knowledge system comes in is when times are tough and there's not a lot of money available. They blend these treatments to come up with new treatments. Under predator control, they use indigenous knowledge like herding, crowding, whips, even fire to a certain extent, and then they make use of indigenous mixed breed dogs to help with predation control. From the scientific knowledge, they also know about, some of them make use of trained herding dogs. They do not kill jackal indiscriminately as science would suggest. And in terms of idiosyncratic, they also make use of other instruments, like I've seen a vuvuzela in the veld as well as a blowing instrument to chase away jackal. And also where they've got Anatolian dogs, they leave the dog alone with the herd. Just a picture of a herder with a few dogs and that vuvuzela I talked about. So in conclusion, The agri-syncretic practice of the Nama herder is a blended, flexible, open, dynamic, and scalable form of pastoralism that could be future adaptable. The fusion of elements gives it a unique character. The adaptability allows herders to respond to changing socio-cultural and economic factors, as well as keeping pace with climatic and ecological shifts. Embedded in the system is that it is scalable across both space and time, further adding to its syncretic and potential adaptability in a changing world. Knowledge system of herders is complex and should be recognized by agricultural practitioners. The herder's knowledge pool could be used by herding schools as a rich source of information. Herders could be important co-producers and disseminators of knowledge that connects isolated academic disciplines that relate to livestock production. Lastly, herding should be considered strongly in future policies concerned with the management of rangelands in variable arid and semi-arid environments. Thank you very much.